Welcome back to 3 Inquisitive Kids. In this video, we will be solving a geometric problem using 2 solutions. We know that angle C is a right angle and CD is 6 units long. We are asked what is the minimum area of triangle ABC. Here, we can represent the area of ABC as 1/2 of the base, which is AB, times the height, which is 6. This is the same thing as 3AB, which means that if we find out the length of AB, we can calculate the area of triangle ABC. So, how can we find the length of AB? Well, we can let AD equal M and DB equal N. And we also see that when we make this angle 1 and this angle 2, we see that when angle 1 plus angle 2 is equal to 90 degrees, and angle 2 plus angle B is equal to also 90 degrees, it means that angle 1 is the same as angle B. This tells us that if angle 1 is the same as angle B, and this is a right angle, and this is a right angle, then it means that triangle CDA is similar to triangle CDB. Knowing that these two right triangles are similar, we can see that when we look at corresponding sides, the ratio of 6 to n is the same thing as the ratio of the side m to 6. So when we simplify this, we get mn is equal to 36. And we can let m plus n equal a number, k. So this also means that we can write m is equal to k minus n. You could also write n is equal to k minus m. In the end, it doesn't really matter. But for now, we're going to use this bottom equation. So we have 36 is equal to n times, we're going to replace the m with k minus n. This is the same thing as kn minus n squared. As you can see, when we look at these two sides of the equation, we can move all the terms to one side to get n squared minus kn plus 36, which is equal to 0. By doing this, we have made ourselves a quadratic equation. This means we can use the discriminant. K squared minus 4 times A times C, which is 1 times 36, has to be greater or equal to 0, which means that K has a minimum value of 12. Now let's go back and see what K really represents. Before, we said that K is equal to m plus n. And when we look at our graph, we see that m plus n is the same thing as the length of AB. So if we know that K is the same thing as AB, we can rewrite it like AB has a minimum value of 12. So when we're trying to find the value of 3AB, which is the area of the entire triangle, 3AB is greater or equal to 36. We just multiply a 3 on both sides. What this means that the minimum area of triangle ABC is 36 units squared. We have another way to solve this problem. First, we know that angle C is 90 degrees and CD is 6 units long. We also can label this side as A, this side as B, and this side AB, as C. When we do so, we can use the Pythagorean theorem. C squared must be equal to A squared plus B squared because angle C is 90 degrees. The area of triangle ABC, which is what we're trying to find, can be represented as 1/2 times A times B. Or it can also be represented as 1/2 times 6 times C. When we just look at this side of the equation, we can see that AB is equal to 6C. This also shows that C is equal to AB over 6. When we bring C equals AB over 6 into the Pythagorean theorem, we will get AB squared over 36 is equal to A squared plus B squared. We can multiply 36 on both sides of the equation. When we see A squared plus B squared, we can think of the inequality A squared plus B squared is always greater or equal to 2 times their product. How do we get this? Well, this is easy to prove. When we take A minus B squared, because it's a number squared, it means it has to be greater or equal to 0. When we simplify it, A squared minus 2AB plus B squared, this is also equal to greater or equal to 0. So then we can move 2AB to the right side of the equation. A squared plus B squared will always be greater or equal to 2 times AB. So if A squared plus B squared is always greater or equal to 2 times AB, then when we have 36 times A squared plus B squared, this is greater or equal to 36 times 2 times AB, which is 72 AB. This means that AB squared is greater or equal to 72 AB. So when we divide AB on both sides of the equation, we get AB is greater or equal to 72. We see that the area of triangle ABC can be expressed as 1/2 AB. Because we know that the minimum value of AB is 72, when we have 1/2 AB, its minimum value is 36, which means that the area of triangle ABC has a minimum value of 36 units squared. As you can see, through both of these solutions, we were able to find the same answer. In the first solution, we used the discriminant. And in the second equation, we used this inequality derived from the perfect square formula. I hope you learned something from this video, and I'll see you in the next one.